marginal, as the Cobb-Douglas utility function. And the marginal utility of x ux equals partial u partial x, which would be alpha x to the power of alpha minus 1 times y to the power of beta. And uy, which is partial u partial y, equals beta x to the power of alpha y to the power of beta minus 1. Okay? So the shape of the indifference curve of Cobb-Douglas function, utility function, would look like this, just in between these two cases. So the straight indifference curve would be perfect substitute, and the L-shaped indifference curve would be perfect complements. Okay? And something in between. One representative case would be Cobb-Douglas function. So we have functional form, utility function, and perfect substitute, perfect complement, Cobb-Douglas. This is so we have already checked perfect substitute, perfect complements, and you see the utility function form will be iq1 plus jq2, and this will be minimum of iq1 jq2. And Cobb-Douglas, q1 to the power of a and q2 to the power of 1 minus a. Here, a and 1 minus a is just a special case of this. It's actually a limited version of this one, because if you assume alpha plus beta equals 1, then we have this form. Is that clear? If we do not, it is fine. It is fine. We do not need the assumption alpha plus beta equals 1. We do not need the sum to be 1. So we don't have to assume this. This is just a special case, and I encourage you to learn this case or to learn this approach. And some point of time later, I will introduce to you the CES utility function. CES stands for constant elasticity of substitution. So CES, constant elasticity of substitution. 固定替代弹性, okay? Constant elasticity of substitution. And we just give the quasi-linear. Some people would read it as quasi-linear, quasi-linear, quasi-linear. Either way. I've heard someone from the US, quasi-linear, 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 someone from Europe. So people around the world just read it differently, but we just know what we are talking about, okay? Quasi-linear, 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 whatever. Okay, Cobb-Douglas. Now we are introducing budget constraint. So we want to choose something we like to consume. Okay? We have our preferences. We prefer something better than, we prefer something to others. Or we like something, or something provides us higher utility level than others. But we need to face something we call it constraints, because all of us, we have 24 hours in a day for all of us, right? And although we have different value or different number of money, in our pockets. So say maybe some of you have $200 with you now, and I may have like $5,000 with me in my pocket. So actually we have different monetary budget constraint, which means our income or our salary are different, okay? So we are facing constraints like of time, of money, of income, or energy. So you cannot just play like playing mahjong for 3 days without taking any break, right? You need to go to sleep for a while and then play, go on playing. So we are facing different types of constraints. And now, let me introduce the monetary ones to you. So given prices of pizza and burritos, so if Q1 denotes the number of pizzas and Q2 the number of burrito, then P1 and P2 are prices of these two types of goods respectively. And Y is the income. So we may put the budget in this function, P1 plus Q1, sorry, P1 times Q1 plus P2 Q2 equals Y. So P1 Q1 means the expenditure on good one, on pizza. Is that clear? P1 is the price for each unit. And Q1 is how many slices we have, how many slices of pizza we have. So P1 Q1 means the total expenditure on pizza. And P2 Q2 is the expenditure on burritos. So the sum, the total expenditure of on these two goods must equals our income. Assuming that we consume these two goods only, no more other things, nothing else, just pizza and burrito. Okay? So this is the budget line. And actually, the better way to put this would be P1 Q1, P2 Q2, less than or equal to Y would be better. Okay? Which means the expenditure cannot exceed the income. Okay? So Q1, Q2, then what would be the intercept on the horizontal axis? What would be the horizontal intercept? When Q2 equals 0, Q2 equals 0, then Q1 would be Y over P1. Is that right? Is that clear? So if all your money, all your income is expended on pizza, so how many slices you may consume at most would be Y over P1. Is that clear? This would be the maximum slices you may have, I mean pizza of pizza. Okay? And how many burritos if you want, the maximum number you may have, it would be Y over P2. So, you know, this equation should be a straight line, right? For example, 3x plus 5y equals 15 is a straight line, right? With negative slope. And the inequality here means the area of the triangle. Because the half plan should be on the left, right? But since Q1 and Q2 cannot be negative, they represent quantity. So Q1 should be greater than 0, no less than 0, Q2 no less than 0. So for Q1 no less than 0, Q2 no less than 0, with this half space, half plane. So we have the intersection of these three, 1, 2, and 3 constraints or inequalities. We have the triangle. Okay? So some points in the triangle, any point, any combo, any combination, any bundle in the triangle, which means what? Which means we can afford these points, this combination of goods. We can afford it because this point satisfy this inequality, right? We still have some income not used up, right? And points on the straight line, on the budget constraint, will satisfy the equal sign, the equality, which means we used up all our income, but we can still afford these points, right? And some points outside the triangle, which means we cannot afford it. We just cannot afford this kind of consumption. Is that clear? So the constraint, which means we can afford it, and they are something we cannot. We do not have enough money. So if one day someone give you another income or another amount of money, then you may make your constraint shift outward parallelly, because once the relative prices are not changed, are constant, then the more money you have, the constraint would move outward, or the triangle would be larger, so that something we cannot afford initially, now we can buy it with more money. Is that clear? So the more money you have, the larger the triangle is. All right? Okay, let me give you an example. Now, I just gave you one. Suppose you have $1,500, and for each X, it costs you, or its price of the price of X is $3, and the price of Y is $5. So you must obey or satisfy this budget constraint. No more than $1,500. So in this case, X and Y, 3X plus 5Y less than. So 500 units of X you can afford at most, right? And 300 units of Y. So this would be the budget constraint, and the budget set. This would be the budget set. What about what about if the price of y, py, for some reason it becomes cheaper from $5, now it is $3. Say if we allow, our government allow something to import from overseas. So if y becomes cheaper, now it will be 3x plus 3y less than or equal to no greater than $1,500. And what happened to the budget constraint? It is still $500, right? And not dollars, 500 units of x. And now it is 500 units of y. This would be the new budget constraint. And you see it's a rotation, rotate outside, right? Outward. And the budget set, which means the area of consumptions you can afford, become larger, right? So when the price becomes cheaper, your purchasing power goes up, right? Your purchasing power goes up whenever the price of goods goes down. What about if px becomes cheaper from 3 to 1? Then you may have what? This many units of x, right? And once again, you may see what? The budget line rotates outward, right? In another way. Is that clear? And your budget set becomes larger again. So event one, the price of y becomes cheaper. Event 2, the price of x also becomes cheaper. So when only event 1 occurs or happens, then the form of the change would be a rotation outward, and it's another rotation. And the reason why the first case we use this as a pivot point to rotate is because px doesn't change, right? Px doesn't change, and the maximum amount you may purchase of x will be the same. Remember, without any change in your income or the price of good x, just make the intercept constant. Alright? And the second event, when the second event occurs or happens, then at that time py doesn't change. So we have this kind of change. Is that clear? And the last thing, for event 1, py becomes cheaper, px doesn't change, we have a steeper or flatter line constraint. Steeper or flatter? Steeper, right? As compared with this one, the yellow line is steeper. Okay? So the first case, it becomes steeper. And the second becomes flatter. Okay. I will meet you at 10:05. Okay, let's take a break. So in the next hour, I will tell you why it becomes steeper and flatter. Okay.